What is sieve analysis? Sieve analysis is a laboratory test procedure in which particles will move vertical or horizontal through the screening mass. Depend on requirement and material particle, different filtering method have two methods, manual sieving method and mechanical sieving method. Why? To determine the particle size distribution, the sieve analysis test procedure may be a good method that has been in place from the past. Where manual sieve method is manually distributed in a place where there is no electricity and is mainly differentiation in a place between large and small particles. Mechanical sieve method are used in a laboratory to ensure quality, and this probability the most widely used method nowadays. When to evaluate the particle size distribution of granule material by allowing the material to move through a small mesh measurement sieve network and weigh the amount of fabric stopped by each sieve as a complete mass friction. How? Clean the sieve using the cleaning brush. Record and load each sieve and pen. Read the specimen in the oven. Weigh the specimen and note the weight. Sort the sieve from largest to smaller. Open the sieve to the last and largest opening sieve to the back. Next, keep the record specimen on the best sieve, then store the complete sieve stock in a sieve shaker. Let the shaker work from 10 to 15 minutes. Lastly, remove the sieve stock from the shaker and record the load each sieve and receive pen separately.
Establish the moisture contents at which fine-grained clay and seed soils change between solid, semi-solid, plastic and liquid states. This test includes shrinkage limit, plastic limit and liquid limit. Liquid limit determines the water content at which the behavior of clay soil change from plastic to liquid. Plastic limit test that involves rolling out a thread of the fine portion of the soil on a flat, non-porous surface. Shrinkage limit test that evaluates the water content of the soil, where further loss of moisture will not result in an additional volume reduction. To represent the moisture contents at which a specific soil's behavior change from solid to plastic, which is plastic limit, and from plastic to liquid, which is liquid limit. It is mainly used on clay or silky soils, as these are soils most affected by expansion and shrinkage due to varying moisture content. When a fine-grained soil can no longer be remolded without cracking, it is called plastic limit. When the soil changes from plastic to a liquid, the soil specimen is just fluid enough for a groove to close when jarred in a specified manner. It is called liquid limit. When a fine-grained soil no longer changes volume upon drying or loss of moisture compensated by air, it is called shrinkage limit. Plasticity index. Soils with a high pI tend to be clay. Those with a low pI tend to be silt, and those with a pI of 0 tend to have little or no silt or clay. The liquidity index is used for scaling the natural water content of the soil sample to the limits. The consistency index shows the consistency of the soil. Soil at the liquid limit should have a consistency index of 0, while soil at the plastic limit should have the consistency index of 1. If natural water content is higher than liquid limit, the consistency index will be negative.
Hello guys, do you know what is the specific gravity? Okay, let me tell you about the specific gravity. And the first one is Watt. Specific gravity is the ratio of the mass of soil solid to the mass of an equal volume of water. It is an important index property of soil that is closely linked with mineralogy or chemical composition, and also reflect the history of weathering. Okay, for the second one is Y. It is relatively important as far as the qualitative behavior of the soil is concerned, and useful in soil mineral classification. For example, iron minerals have a larger value of specific gravity than silicas. Okay, for the third one is When. It gives an idea about suitable of the soil as a construction material. Higher value of specific gravity give more strength for road and foundations. It is also used in calculation of void ratio, porosity, degree of saturation, and the soil parameters. Okay, for the fourth is Where. in soil mechanics, the most important specific gravity is that of the actual soil grains and is given by symbol GS. From the above definition, it's seen that for a soil sample with a volume of solid Vs and weight of solid is Ws. W is equal to weight of water, and if the sample has a mass of solid, equal to Ms. Every W equal to density of water equal to 1.0 mg meter cube at 20 Celsius. For example, GS equal to Ms over Vs PW equal to Ws over Vs YW. Then density of the particle Ps is defined as Ps equal to Ms over Vs. Therefore, GS equal to Vs over PW. For the fifth is how. Specific method of test for determining the particle density. For fine, medium or coarse soil, the standard specifies the use of a 1 liter gas jar fitted with a rubber bung and a mechanical shaking apparatus which can rotate the gas jar end over end at 50 rpm.